Hello everyone and welcome to our channel Quaint Cosmos. Today's topic of discussion is a question. The question is why the curl of electric field is zero in electrostatics. That is the question. And that is the topic of discussion in this video. So you know there are two fields, electrostatics is there, again electrodynamics is there. And in electrostatics charges don't move, but in electrodynamics charges move. But in electrostatics, since charges don't move, that means those charges don't produce magnetic field. They don't generate magnetic field. Okay. And since magnetic field is not generated, so there is no question of changing magnetic field, change with respect to time. Okay. Since change is not there, change of magnetic field with respect to time is zero, therefore the curl of the electric field becomes zero. So how I am saying this thing here? You know, Maxwell's equations, actually that is a set of four equations, and the third equation is known as Faraday's law of induction, and that law is available in the form of equations. Two equations are there, both are same, but forms are different. Differential form is there, again integral form is there. So according to differential form, it is nabla cross E is equal to minus del B del T. And this equation you will find in the study of electrodynamics. Okay, so this is the third equation from the set of Maxwell's equations, known as Faraday's law of induction. So nabla cross E is equal to minus del B del T. Here E is electric field and B is a magnetic field. Small t is there, that is time. And nabla is a vector operator that is known to you. Unit matrix is not unit matrix here, it is a vector operator. Anyway, you know meaning of curl. Meaning of curl means something is rotating around a point, rotating or circulating around a point. And curl is defined only for vector fields, not for scalar fields. So you know electric field, that is a vector field. So curl is defined for any vector field, such as in fluid mechanics. If you study fluid mechanics, then you can see that curl of velocity is used. And that represents what? Rotation of the fluid elements. So whenever curl is involved, that means rotation is present. And if curl of the vector field becomes zero, that means there is no rotation at all. Okay. So same thing happens here in the field of electrostatics. Since charges don't move, so there is no question of changing magnetic fields, because magnetic field is not generated. And therefore, the right hand side of Faraday's law of induction minus del B del T, that becomes zero. Because B is zero, so automatically minus del B del T is zero. Therefore, curl of E, that is nabla cross E, becomes zero. So this is the answer to the question. Why in electrostatics curl of the electric field is zero? This is the answer to the question. And you know that there are so many applications of this thing, like in generators. Then again in case of wireless charging. Okay, in transformers. So means which application I am talking about right now? I am talking about Faraday's law of induction. Here in all these cases, Faraday's law of induction is present. Whether it is generator, means by using generator, you know, electricity is generated. So actually induction process happens there. Rotating magnets are there. And that rotating magnets cause the generation of electricity. Again, in case of transformers, wirelessly power is transmitted. Okay. Again, in case of wireless charger, same thing happens. Okay, so many applications are there. Again, if you study light or radio waves, okay, even Wi-Fi, in all those cases, you will find these things: changing electric field, changing magnetic field. Both are present. Actually, changing electric field causes changing magnetic field. Again, changing magnetic field causes changing electric field. Anyway, I was not talking about all those things. The main topic of discussion was why Karl law of electric field is zero in electrostatics. Okay, so in short, the answer is, since magnetic field is not present, or changing magnetic field is not present, or changing magnetic field is zero, that's why Karl law of the electric field is zero. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.